Yeah, Shunay comes everyone. Let's start off. Hope everyone has gone through the notes. Like I said, instruments are quite important. After today's class, you can start solving. HCV chapter is almost done. There are, I think, 85 questions. You can start doing everything. Others, do switch on your cams. I hope everyone went through the notes. So last class we did was MetaBridge. And this was the important thing, the third precaution. You should balance on the middle 1/3. Let's do one question before going ahead. We'll be doing potentiometer today. That is the last instrument we have. Let's get this. Again, I'm telling you, it is important you go through the notes every time after every class. If you don't do that, you won't remember things. And when you open the book to solve, you will think things are like, all new and all. So don't do that. Please do revise on regular basis. Get this thing. We'll wrap up with current today. Next class, we'll start off with waves. Let's get this thing. Waves is pretty interesting. We will learn a lot of things. How to destroy bridges. How to find how fast the vehicle is moving. We can create vibrational warheads. How tsunamis, you can destroy stuff. So a lot of interesting stuff in waves. Cams on, everyone. If you're not sleeping, you should switch on your cams. Trisha is going to Barbie movie today. Oh, sorry, it's supposed to be secret. Huh? No, she's not going. She's going to Oppenheimer. How to do this thing? Rishi, finished watching movies? Dono dekh liya?
Watched one.
Which one?
Oppenheimer.
Last time someone was saying, sir, anyway, Oppenheimer समझ में नहीं आएगा. At least Barbie तो देख लेते हैं. Answer for this, everyone. It's a good one. Get this. We have a circuit. It is balanced at a length x. Now you made the diameter of the wire is doubled. Then what will happen to the null point? No re Brenda. That's right. Think. Where is Ammu? Ammu has not come yet. You're having your dinner, finish it off and do switch on your cams. Answers, everyone. Easy one, this is. Do you guys remember the formula we derived? Resistance Rx is equal to R into L minus X by X. This is independent of area, right? It doesn't matter if you increase the radius. When you increase the radius, what will happen on both the sides? The resistance will increase by the same factor, isn't it? What will happen to the resistance? This resistance will become rho length by area. That is rho x by area. This side will become rho L minus X by area. Agreed? The area term will always cancel out now when you take a ratio. So it won't matter. The answer will remain X. Easy? Check it out. All clear with this? This instruments part, right? After today's class, I'm telling you again, start solving today only. These instruments, HCV, I think 46 to 55 or something. There are 12, 13 questions. Do them tomorrow maximum. They will, you'll remember much better. Even last class we did, ammeter, voltmeter, around 9 questions. That should cover most of the models. Turning the page. Any doubts on this? Easy one. Divyanshu, clear? Gauri, clear with this?
Yes.
Next thing, potentiometer. Potentiometer is not difficult, but the main thing you should know how the working is and how the diagram looks. If you know these two things, question is quite easy to solve. So what do you do with a potentiometer? It is used to measure the unknown EMF of a battery and internal resistance. So we are finding the unknown EMF and the internal resistance. So how does the circuit look like? This is an R known. This is EX, which I don't know. This is RX, which I don't know. This is EP. This is RP. This is a potentiometer wire. Resistance is R0 and length is L. This is called primary circuit. This is your secondary circuit. So in this diagram, right, if you observe, EP is the primary battery car in EMF. RP is the primary battery car internal resistance. R0, L, RK, these values you know. Our job is to find, we need to find EX and RX. I think everyone should draw this diagram there. Put it down, draw the diagram properly. Because every question that we do, the question always starts from this diagram. Most people, the reason why they find potentiometer difficult is because they don't draw the diagram and they don't understand what the hell is happening. Please note down the diagram. Because every question that I show, this diagram will keep coming. So you can refer to this thing every time when you solve. Put it on properly. So that blue shaded thing, thick wire is the potentiometer wire. The jockey moves on that wire.
So what have you written just before L in the known?
R0.
Okay.
Potentiometer wire, resistance is R0. the length of the wire is L. Clear? Copied everyone? Labdi, clear na? Kavish? Now let's see how do we use this circuit to find EX and RX. Turning the page. So first let's find EX. So to measure EX, open the switch. So keep the switch open. Remember, there's only one switch here. And move the jockey till the bridge is balanced. What do you mean by bridge is balanced? Galvanometer mein current is 0. Now redraw the circuit. Since that thing is disconnected, we don't draw it only. So this is the jockey. So this is EX, this is RX, this current is 0. Let this point be A and let this point be B, and let this get balanced at C. And let this length be X. And this would be EP and this would be RP. Now tell me one thing. If this current is 0, isn't this current also 0? It's the same branch, right? Means current won't flow in the EX battery only. Agreed? So whatever current will flow, that will flow only in the primary battery. And how much is that? So I is equal to E primary by R primary plus R naught. Everyone agrees with that statement. The current in this thing will be this wire resistance is R naught. So total resistance will be RP plus R naught. That is the current which is flowing in the primary battery. That would be E prime plus R prime plus R naught. Everyone agreed with that? Now, if I call this point A dash and I'll call this point C dash. Tell me one thing, why is the current not flowing through the galvanometer? Since Ig is 0, the potential difference Vc minus Vc dash should be equal to 0. Because the current through the galvanometer is 0, the potential difference should be 0. Therefore, Vc is equal to Vc dash. Makes sense? If there is a potential difference, current should flow through the galvanometer. And we know Va is equal to Va dash. Why? Same wire. A and A dash are connected by same wire. Now listen to this thing. This is the main point in the entire potentiometer. Since the current is not flowing, can I say potential difference across AC should be equal to potential difference across A dash C dash? The potential difference across this wire should be equal to potential difference across this wire. Because A and A dash are same, C and C dash are same. So VAC should be equal to VA dash C dash. Everyone agrees with this statement. Entire potentiometer mein, this is the main concept. If you understood this thing, question ho gaya. Ask me if you're any confused here. Stop me here. Ask me if you're confused. Anything that you didn't understand so far.
So VAC means potential difference across A and C.
Yeah. VAC मतलब potential across AC.
सर बट जो A के ऊपर वाला जो पॉइंट है वहां पे भी तो सेम ही पोटेंशियल है तो वहां पे क्यों करंट फ्लो हो रहा है?
अरे ये वायर है रे गॉड, क्या बात कर रहे हो? शौर्य रेजिस्टेंस भी 0 है ना?
ओके हाँ
क्लियर? and दूसरा Ohm's law is applicable across resistor, right?
Okay.
Now, what is AC? Current in the circuit into resistance across AC. What is A dash? C dash. EX minus IG into RX. If there had been a current in this branch, that was the formula. But what is IG? IG is 0. So what is I? E prime by R prime plus R naught into RAC will be resistance per unit length into X. पूरा wire का resistance is R naught per length L. X के लिए what is the resistance? This would be EX and IG is 0. Therefore, I get EX is equal to E prime R naught by L into R prime plus R naught into X. I know everything here. You can find from EX. So this is proportional to X. EX is proportional to X. So more the length of the wire balance, the more the potential difference. I don't want you to remember this formula. I want you to remember this concept that the potential difference will be same. उसके बाद it is simply Kirchhoff's law in solving an equation. Check this out. So we are assuming current as IG, which is 0 flowing through that. So potential difference will be EX minus IG RX. Please have a look at the steps. Is this clear?
So resistance is linear function.
Clear? Can I turn the page?
Yes.
Let's try this question. So there's a potentiometer wire AB of length L, resistance is 9R, is joined to the cell of EMF E, internal resistance R. The cell का EMF is E by 2. So primary battery is E and the unknown battery is E by 2. तो यहाँ पे unknown battery की EMF दे दिया. Now he is asking, the current shows no deflection. What is the balancing length? I'm asking this X का value. Question is clear? Try. I'll give you a minute. Think about it. Let it be wrong. I don't care. But you just try. You understood this concept. No? If you want, you can refer this once. Have a look at this. Don't apply the formula. Directly apply mat karo. Just try to solve it. Put a circuit. You know, say current is this thing in this 0. Then you say potential difference across this is equal to this. So literally try to derive the whole thing again. Take 2 minutes. Think about it. Try to put it. I'll show you how to do. You do that, you will learn. If you just try to just put the answer, you will not understand what the hell is happening. Take 2-3 minutes, figure it out. Then I'll show you. Someone is confused, please ask. I'm sure you understood the basic concept. Basic concept is current in this branch is 0. Potential difference across AJ should be equal to potential difference across the battery. बस वही concept था और कुछ नहीं है. Try. Everyone should try.
So can you go back 1 second?
Hmm.
One second.
Done? Help you?
Sir, 1 second.
Try. I'll just read out the circuit.
Sir, 5L by 9.
5L by 9 is the answer. Let's show you. Then पूरा वायर का डिस्टेंस कितना था? 9R. Galvanometer, and you connected it somewhere here. This is E by 2. This is small r, 2R. Whose value is fine. Since the bridge is balanced, the current IG is 0. So in this, I is 0. So whatever current flows will only flow in the primary circuit. So I will be E by 10R, R plus 9R. This point is A, this point is C, this point is A dash, and this point is C dash. Potential difference VAC should be equal to VA dash C dash. This will be nothing but I into resistance across A into J. And this would be nothing but E by 2 minus IG into R2R. I hope you're getting how am I writing this statement? How am I writing this statement? Remember non-ideal batteries? This is the potential difference, no? E minus IR. When you have an internal resistance, potential difference across the battery will be E minus IR. That's why I'm writing E minus IGR every time. Kavish, you got it right. So current is how much? E by 10R. What is resistance across AG? Resistance of the full wire is 9R. Length is L. Into AG ka length, I don't know. That's what I have to find AG. This will be E by 2 since this term is 0. E will cancel. R will cancel. We get AG is equal to 5L by 9. Check. Easy.
Sir, that VA minus VB equal to E minus R, that also we got from Kirchhoff's only, no? If we consider it.
Kirchhoff's only. Bhai, na? You are writing from VA dash minus this thing is VC dash. Everyone getting this? Okay, understood this. Let's see one more like this. We'll do 2-3 rounds, don't worry, you'll get the hang of it. But the main idea is always that. If you should know your circuit, you should know what is happening, you'll understand the questions. There's nothing to by heart any formulas. Clear, na? All got this thing. Danya, Labdi, clear. Abhiksha, Chirayu.
Yes.
Arushi. Going ahead, next one. Next one. Get this. This is more easy.
सर 2/3 आ रहा है.
Again, current is 0. Whatever current flows will flow only through this wire. And he's saying wire ka length is 1 meter. He didn't give the resistance. Chalega. So current I will be 6 by R. So V AC is equal to V A dash C dash. So this is nothing but I into resistance across AC. This will be 4 volt minus I into 1 ohm. I is anyway 0. So I will be 6 by R. And this will be wire ka length is 1. So R by 1 into the length AC. This is 4. This would be 0. RR will cancel. AC is equal to 2/3 meter. There is a faster way to do this. You have 6 volts for the full wire length L. The 4 volts is for how much wire? So X is equal to 4/6L or 2L/3. Isn't that faster? You are applying 6 volts for the full wire. Then 4 volt will be for how much wire? Oh yeah, na? Straight proportionality. Check. Easy.
This we can use when there is no internal resistance of the.
Because internal resistance nahi, you can do this. But ठीक है ना? Stick to this regular method if you're confused. All clear with this?
Sir, could you go to the previous question one minute?
Clear? Clear? Next one. This was asked in the JEE exam once. They said they gave a circuit. This is E pre, this is RP. Now here you have taken 2 batteries. Galvanometer and you balanced it. So E1, E2, both are in same polarity. Same polarity meaning both the positive terminals are connected in the same direction. And the balancing length is L1. So question was given like this. 2 batteries are kept it in same polarity and balanced by a potentiometer. The balancing length is L1. The same 2 batteries are connected in reverse polarity. So E1 and E2. But this time plus, minus, minus, plus. They're in reverse polarity. Balancing length is L2. The question is find E1 by E2. How to do? Get it? Easy one. This was a straightforward question in the exam.
So they don't have the internal replacement,
Where
the E1 and E2.
which one? Even फर्क नहीं पड़ेगा ना, current balancing length में current तो zero anyway. ना, even if you have, you don't have, it doesn't matter.
Okay. So means in first case positive to positive is joined. No?
Yeah.
Okay.
What to do? Remember this result we just now derived? E is proportional to X now. So in the first case, E1 plus E2 both will add up in the same direction. E1 plus E2 is proportional to length L1. Second case में E1 minus E2 is proportional to L2. Divide them. You get E1 plus E2 by E1 minus E2 is equal to L1 by L2. हो गया ना? Simplify this, you'll get E1 by E2 का ratio. L1 minus L2 by L1 plus L2 types. Easy. Component to dividend. You can do anything you want. Or just cross multiply and get E1, E2 common and finish it off. This comes from that result that the EMF balanced is proportional to the length balanced. So E1 plus E2 together are balancing L1 and E1 minus E2 is balancing L2. Just finish off with the proportionality. This is a straightforward question in mains and bits. They are given numbers though I gave L1 and L2. Easy? Sure? Can I turn the page? Clear na everyone? Next one. Let's do a little better one. Hasni, clear so far? Rishi, Kavya? Trisha, clear na? Let's do this one. You have two batteries and two resistors in parallel. He's asking find the point where it balances AN ka length. Get this, how will you do this? Let's see how will you approach this. How do you do this?
Sir, one minute.
Try. You got 2 minutes. It's a good question. If there is one battery, you know how to do, no?
Sir,
Suddenly
we
there are
can-
2 batteries, you're confused.
we can do like that. वो आपने फॉर्मूला बताया था ना, E1 R2 plus E1 R2 उससे R वहां से R equivalent और
हाँ,
R
तो
equivalent.
चुप रहो ना, तो करो ना खुद, क्यों बोल रहे हो? Over excited. You are messing up with everyone else's career. But they don't know how to do this thing on their own. And कल एग्जाम में थोड़ा मार्क्स कम आए, they'll get angry and they'll become a terrorist and they'll come and shoot you down. क्या करोगे? हो सकता है butterfly effect.
That was dark.
अरे इंडिया में तो नहीं होगा, यूएस में तो वही होगा. फिजिक्स टीचर टीचिंग टफ पोटेंशियोमीटर क्वेश्चंस शॉट डाउन. पॉसिबल. क्या बात है, यूएस में कुछ भी हो सकता है अभी तो. इट इज लाइक दैट ओनली आई गेस. Physics teacher will be wearing, you know, full protective suit and going into the class. Option A 1/6 नहीं आ रहा कविश. ये तो नहीं है आंसर. I hope शौर्य बड़ा hint दे दिया. Did anyone figure it out? If there is one battery, you know how to do. So how to do that? Make it one battery. वो diagram थोड़ा छोटा दिख रहा है. But I think that even E2 are in opposite direction. Right? I think Kavish, maybe you did that mistake. It is actually like this. Even E2, no, it is looking little thoda ye, but they're actually in the opposite direction. So this was 2 volt. This was 2 ohm. This was 4 volt. I think Kavish, you took both in same direction, na?
Yeah, sir.
नहीं वो diagram थोड़ा छोटा दिख रहा है. So this thing, how will you replace this? R equivalent is R1, R2 by R1 plus R2. So that would be 6 to 12, 12 by 8, 4 by 3 ohms. And E equivalent will be E1 R2 minus E2 R1. यहाँ पे minus आएगा because both are on the opposite. E1 would be, how much is this? 2, 6, 4, 2 by 2 plus 6, 8. That will be 12 minus 8, 4 by half volt, na? That full setup is behaving like an half volt ka battery. Please check this thing first. Then just read out the circuit. So if I just read out the circuit here, so this whole thing looks like a battery. Resistance E naught ka value is 12 volt. This is 8 ohms. Potentiometer wire. Wire ka resistance is 4 ohm per meter. Total length is 4 meter. 4 meter ka length, and resistance per unit length is 4 ohm per meter. मतलब total 16 ohms था. And you replace this with one battery with a resistance. Battery ka voltage is half volt and resistance is 4 by 3 ohms. Is this fine, everyone? So R naught ka value will be 16 ohms. So this is point A, this is point C, this is point A dash, this is C dash. Let the current be I. We have current I is equal to 12 volt by 8 plus 16. That is half ampere. Voltage across AC is equal to voltage across A dash, C dash. So that will be current into resistance across AC is equal to EMF of the battery, which is half volt. Current is anyway 0. That will be minus I into 4 by 3. This term is 0. Current is half ampere. Resistance of AC will be, he's asking to find that only, no? That would be 4 into the length, let it be X. because resistance per unit length is 4 ohm per meter into x is half. Half will cancel. X is equal to 1/4 meter or 25 centimeter. Please check. If you can just combine both the batteries and make it a single battery, you know how to do this thing, right? So the main idea is that you have to convert the two batteries into single battery. Do check this out. And both are in reverse polarity to formula. Yes, this is the case where we did here. Combination of batteries may taught you. Hope you remember this. That's the reason I said this is important. You can ask it in multiple places. We have done a question like this. You could use it here. Do check it out. Clear? Any doubts on this? Anyone not clear, not convinced, please ask. Clear? Can we go ahead? So there, if you see all these 4 problems are based on the same model there, we are just finding EX or we're finding the balancing length. Now we have to find that RX, internal resistance also. Let's see how to do that now. Next thing. You know, how does a potentiometer look like actually in real life? The one which you use practically. It looks like this. It's actually a small thumb size. We don't need this in the portion, just for your explanation. And this is how it looks. So how this works, you know, here you can see this metal track there. I'll just show the circuit. See. So this is the potentiometer wire. So we kept the battery here. So in this thing now, this is 0.1. This is 0.2. This is 0.3. So you connect the wire 1 here. You connect 2 here. You connect 3 here. So 2 is the jockey. And look at this diagram here. If you look at this diagram here, you'll observe that is a metallic track. Inside you have a circular track like this. So whenever you rotate this knob, when you rotate this knob, what happens? If this wiper is there, the wiper will rotate. So when the wiper is rotating on this, that's like a jockey moving on the wire, na? Can you observe? So when the knob is rotated, the wiper rotates actually. So this wiper is your jockey here. And this resistive track is your potentiometer wire. So in this diagram here, this is 0.1, the jockey is 0.2, and this is 0.3. This will be the size of your thumb. Both chota hota hai actually. You can just put it on a circuit board and you can use this. Did you ever play with your remote control cars when you increase or decrease the speed? What you're actually doing is changing the resistance of the circuit. So current changes and the speed increases or decreases. You're actually using a small size potentiometer inside. Or you can say resistance controller. You're getting how it works? So the one which you see in the lab is outdated and it is only for experimental purpose. No one uses it in real life. These things are much more efficient and much better. Clear? Just a small idea.
Actually, that potential wire is a circle में है ना? Okay.
हाँ, यहाँ पे circle में.
Okay.
Circuit में आपको you can draw however you want, ना?
Yes, sir.
All clear with this? How does the circuit look? Great. Now, how to find RX? We found the battery ka EMF. We want to find the unknown resistance RX. So to find RX, first close the switch and balance the bridge. Again, draw the circuit. If you observe every time I draw a circuit, the moment you draw the circuit, you understand what is happening everywhere. This is E prime, R prime, and this is R naught. galvanometer. This is balanced here. Now we also have a resistance like this RK. This is EX and RX. Now, if this current is flowing here, now see what happens. When the bridge is balanced, the current in this galvanometer is 0. If this current is 0, this current is also 0. Can you tell me why? Logically so. If this current is not 0, meaning some current is entering from here, and this current is not coming back now again. Whatever current has to come out of the battery should go back to the battery. So if you say that current is 0, this current branches also should be 0. So all the current is flowing in the upper circuit. And for the lower circuit, the current is flowing in the lower circuit. So basically both the circuits will behave independently. So in this case, the primary and the secondary behave independently when bridge is balanced. They just behave like two circuits which the current is flowing independently. Behave independently when the bridge is balanced. Okay. Now, what is I? I will be E primary by R primary plus R naught. What is small I? EX by RX plus R known. This point is A, this point is C, this point is A dash, this point is C dash. So potential difference across AC is equal to potential difference across A dash, C dash. Story is still the same. This would be I into resistance across AC. Let's call this length X. This is equal to EX minus I into RX, or you could have also written this as I into R known. Do you agree? Because both are in parallel, no? The potential difference across RK should be equal to potential difference across EX and RX. Both are parallel. You could have done that, but okay. Substitute the values here. So this would be E prime. Again, there's no need to remember the formulas, but remember the process what you're doing. And resistance across this will be R naught by length into X. EX I already know. IX will be EX by RX plus RK into RX. The best thing would be use this formula here. I would be EX by RX RK into RK. Now observe one thing here. I know everything. I know EP, I know RP, I know R naught, R naught, L, X, EX, I know RK, I know RK. This is the only thing whom I don't know, isn't it? I know everything in that equation except RX. Just shift everything that side and solve. You'll get RX ka value from here. Please have a look at this, what we did. The only difference now is if you close the switch, current will flow in the lower circuit. Why do we need the current to flow? Think about it once. Tell me one thing. In the first problem, why didn't you get RX anytime in any equation? Why didn't you get RX in any
क्योंकि
equation?
इधर galvanometer का current
Because ये current 0 हो रहा था. हर बार this current is becoming 0. So until and unless if the current flows in the RX, you can't find RX, right? Or else every time it will become 0. So you need to let the current flow through RX. That is the reason you have to keep one more resistor for the current to flow. Please have a look at the steps. These are the two things. You know how to find EX and you know how to find RX now. Check it out. Do have a look at this step by step. Anyone not clear with this? Do switch on your cams if you're done with your dinner. Clear? Can I turn the page? Now, the same thing, they can ask you this question in another way. They will say, EP, RP, we have the potentiometer wire here. Galvanometer, and this is there, and there is a switch. RK, EX, and RX. So they'll make a statement like this. When switch is open, the balancing length is L1. So when the switch is open, EX will be proportional to L because there's no current. When switch is closed, balancing length is L2. Now the current will flow through the battery and the resistor, internal resistance. Now the EMF will be EX minus I RX will be proportional to L2. Isn't it? This is the voltage, no? EX minus I RX. So EX minus I RX is equal to L1 by L2. This is another way of solving the problem. From here you can find RX.
Sir, when switch is open, then it will behave like the previous case. No?
First case, now.
Yes, yes.
When you close the switch, current will flow, no?
Yes, sir.
There, this is a kind of question they can frame based on length, and you need to find the ratios. Let's see a question on this. Clear? Let's see a question. Let's get this. Just be careful here. यहाँ पे primary and secondary are reversed. This is primary, this is secondary. ऊपर नीचे किया बस. This is primary. This is secondary. The circuit is simply up, it was shifted up and down. Hope you're able to visualize. Get this thing. This is the exact thing which we did right now. This will have both the cases, measure Rx and measure Ex. Try. If you got this, you understood the whole potentiometer thing. Give it a try, 2-3 minutes, and I'll show you. I'll send you a sheet on this thing. All instruments ka sum. In that sheet, anyway, we have done half the questions I already showed. The remaining half the questions I'll give you as a homework. The first thing, start doing HCB today. First, start with instruments. I'll give you the number of the question ka numbers also. I hope capacitors everyone is done by now. So you have to start current now and take a deadline till next Wednesday, 1 week time. 1 week, if you do every day, even 10 questions, you'll reach 70 questions in a week. HCB, there are 84 questions. I'm sure you'll be able to wrap it up. Keep solving parallelly. I know things have been stressful. Bear with it for another 3.5 months. Things will start settling down. Again, draw the circuit. Always draw the circuit. First, open the switch, draw the circuit, solve. Second, close the switch, draw the circuit, solve. Make 2 different circuits and solve. You will see the answers. Yeah, Saturday will be starting with waves. Waves is little more easy. Like I said, it is more of a formula based and result based. As long as you know the formulas and the results of what to what, questions will come. This will take us 3 weeks. Big chapter. And then we have wave optics, magnetism, EMI, AC modern. It should be done before Diwali. Try. I'll give you 2 minutes for finding the battery KMF. Let's see. The first part, let's draw the diagram. E is 12. Yeah, that's right. Get smaller also. Right, Kavish. The first part is right. So first thing, the switch is open. That means the 10 ohm ka resistor is useless. This is R. So this is your galvanometer and this is balanced here. This is how it is connected. This main battery ka voltage is not given. Now here we are asking reverse actually. I know EX, I don't know EP. So EP, I don't know. Okay, battery ka, this is no resistance for RP is not there. Great. Let the resistance be R0. So when the bridge is balanced, the current in the galvanometer is 0, means all the current will flow only in this wire. So I will be E prime by R0. Let's call this point A, let's call point this C, let this be A dash and let this be C dash. So VAC is equal to VA dash C dash, which is I into resistance across AC is equal to, this would be 6 minus I into small r. This term is 0. So I will be E prime by R0. RAC will be R0 by length, and the balancing length is L by 2 is 6. R0 will cancel. EP is equal to 12. Check. Is this clear, everyone? Like I said, every time it is the same story. Draw the circuit. VAC is equal to VA dash C dash. Current in the galvanometer is 0. Find the current in the battery, E prime and EX, and finish it up. Do check it out. Now you're closing the switch. Redraw the circuit. Try again. I'll give you a minute. I'm sure by now you're getting a bit of hang of it. Try. Kavish, you're right. Shaurya, you're wrong. Right, Rishi. Not D, Ray, Vrinda. You got the voltage right, you messed up the smaller. Same thing. Let's read out the circuit. This time you have 10 ohms, battery, R, 6 volt. This is a potentiometer wire. This is your battery. Now I know the value of this 12 volt. This is the galvanometer and this is balanced here. This value is R0. Now he's saying the balancing length is 5L by 2, 12. So let this current be small I, this will be I and this will be I. Galvanometer mein current is 0. This is capital I and this is capital I. Capital I is 12 by R0. Small I is 6 by 10 plus R. This is A and this is C. This is A dash and this is C dash. The voltage across AC is equal to voltage across A dash, C dash. So this guy would be I into resistance across RAC. This would be EX minus I into RX. Or you can also write as I into 10. Both are same. You can take any one. B, right, Divyanshu, both of you got it. So this guy will be 12 by R0. RAC will be R0 by L. And length is given 5L by 12. And small I is 6 by 10 plus R into 10. R0, L will cancel. 12 will cancel. You end up with 5 is equal to 60 by 10 plus R. 5s are 12s are 10 plus R is 12. R is 2. Do have a look at this.
Sir,
हाँ शौर्य.
sir, EX upon EX minus RX equal to L1 by L2 लगाएंगे, उससे भी आना चाहिए.
But I का वैल्यू पता होना चाहिए ना.
हाँ, तो I जो है दूसरा वाला इक्वेशन है ना, EX upon RX plus RK, वहां से 2 equation 2 variable
आना
तो
चाहिए.
उधर से 10 आ रहा है, पता नहीं.
You must have messed up the calculations. Check करो.
Okay.
Do have a look at this what we did. So this thing, right? You can use EX minus IRX or we can use this. I'm using I into 10. Both are right. Any doubts on this? Please ask me. Quite a good question. This question teaches you how to get both RX and EX. Everything you'll know. All clear? Any doubts? Anyone not clear with this? Clear? Go ahead. Next thing. Now, listen carefully. There are some precautions. So whenever using a potentiometer, these precautions are more important. They can be asked in your lab mein practicals or HSC or entrance में multiple choice questions also. First precaution. E primary should be greater than EX. You're getting that? Simple reason. If the primary battery is less than EX, see what happens. Example. So this is your primary battery. This is your this thing. I'll take some examples for our understanding. Let's say this thing is 10 volts, and let's say this thing is 20 volts. So you're taking E primary is greater than EX. Now remember nodal analysis, you can take any point as 0, right? So I'll assume this point is 0. Then what will be this thing here? Anyone?
10.
10, agreed? If that is 10, this is also 10. Then this is also 10. So if this is 10, how much is this?
minus 10.
Minus 10, now let this be
Yes.
0. So यहाँ पे आएगा minus 10. This is 0. Now you tell me on the bridge, if you look at the voltages, this is like 10, 9, 8, 7, 3, 2, 1, 0. Will you get minus 10 anywhere on the bridge? Means VC will never be equal to VC dash, na? That means the current IG will never become 0. Are you getting the point? So this will be VC dash, and this will be C. This will be C dash ka point. You're getting it? We will never find minus 10 volt on the wire. Therefore, IG will never be equal to 0. Bridge will not be balanced. You can't solve. No matter how much you move the wire, you will not find a point where the current becomes 0. So you always have to make sure the primary battery voltage is greater than the secondary. Clear? This is the first precaution. Any doubts on this? I hope you got the example. Clear, na, Nanya? Hasni? Clear? Divyanshu? Clear? Anamay? There, Anamay? He's not there. He's sleeping. Anamay, are you there? He's in a theater, kya? Possible. Next thing. Second thing. E primary and EX should be in same polarity. Why? See what happens. Till now, if you observe all the circuits which we drawed, how did we draw? If you remember the first circuit we drawed also, this was plus, minus, this was plus and minus. They were in same polarity. The plus and plus were together. But let's say for the first time you messed it up, by accident you connected the battery in reverse. Now let's say you have chosen this battery ka voltage is 50 volts. This is 10 volts. Is the condition 1 satisfied? E primary is greater than EX. But now see what is the problem. If this is 0, how much is this?
50.
50. This is 50. This is 50. How much is this?
60.
60. Or you have 0 hoga. So 40, 30, 20, 10. Will you find 60 anywhere?
No, sir.
You'll never find 60 anywhere. Bridge again balance nahi hoga. Will not find 60 volt on the wire. Again, IG will never be 0. So this is also gone. So here's the second precaution, you have to be careful. Clear? Check it out. The third precaution is the most important one and little more tougher one. Next one, the third precaution. R primary must be, or R not, the wire guard resistance should be much greater than RP. This is one of the little less understood thing. Now, why this happens, let's see. So this is EP and this is RP. Now tell me one thing, when you take a battery like this, do you actually get the full voltage across R0?
No.
Because of this internal resistance, it will eat away some of the voltage, isn't it? So even though you're saying namesake ke liye battery ka voltage is EP, in reality you're getting less voltage. Right? Even though the battery ka EMF is EP, right? The voltage across R0 will be EP minus I RP. Agreed? Which is less. And if this voltage, if this EP minus I RP becomes less than EX, then isn't condition 1 getting dissatisfied? What is the condition 1? The voltage of this across the wire should be greater than the EX, na? EP, then bridge won't be balanced. Then condition 1 fails actually. So even though you said EP, the problem there is the voltage will be less. So bridge will never be balanced. Or IG can never be 0. Let me take an example. So example, let RP become equal to R0. Okay. And let this guy be 100 volts. And let's say RP is 2 ohms and R0 is also 2 ohms. Simple example. Now tell me one thing. If you have two resistors in series, both are equal, what is the voltage across them? What will be the voltage across them? This voltage will be 50 volts. And this voltage will be 50 volts. Does everyone agree with this? Even though battery ka voltage is 100, how much are you getting on the wire? Only 50 now. Because that RP has eaten away half of the voltage. And let's say yahan pe maine battery ka voltage liya 60 volt. Now, according to condition 1, the 60 is smaller than 100. So condition 1 is satisfied. But you tell me, if this is 60, will you find 60 volt ka difference here? Are you getting what I'm trying to say? So in this scenario, what is happening, right? So in this example, the voltage across R0 is only 50. So even though battery is 100 volts, the wire is behaving like a 50 volt battery. The bridge will not be balanced. Wire gives only 50 volt and can't balance 60 volt battery. Is this clear, everyone? Hasni, clear? Vrinda, got this? Anamay? Gauri, cams on. Chirayu, Rishi, cams on, everyone. These are the 3 precautions you have to be careful. Do have a look at this. First thing, E primary is greater than R primary. Second thing, EP and DX should be in same polarity. Third is this. Clear? Let's see one question. Let's get this.
So that is closed now.
Which one is closed?
Nothing, sir. Sir, is it 2 meters?
Someone said. Right. Did you observe one thing?
Opposite
This is plus,
polarity.
this is minus, this is minus, plus. Bridge will never be balanced. Precaution 3 gaya. Be careful. You know, 2 kab aayega? If you take same polarity, 2 aayega.
Sir, I didn't notice. Okay.
Be careful. Opposite polarity. Bridge will not be balanced. इसीलिए smartly 2 का आंसर भी है इसमें. Because people know they will do something like that. Be careful. Bridge will not be balanced. Clear? So there, that is about the potentiometer. Last thing, post office box. Just a concept. So the reason why we call this post office box is because they actually use it in post office. Now, even the nowadays, right, when we think about the post office, now we think about letters and all. But whereas in reality, you're talking in 1800s, okay, 1850s, 70s or 1900s that time, and there were no phone calls or anything. You can say a post office was one of the most advanced institute or technological advanced institute. So what they used to do now, they used to have some problems actually, especially, right, post offices were specially used for military purposes. Whenever you want to send messages to a military installation or something. Meaning, if you ever observe an old movie, now, did you ever see a scene like this? The hero gets a message. Father serious, start immediately. Kabhi dekha ye scene? Just 3 or 4 words. The reason because it is very expensive to send a message. It is pretty expensive to send a message. You know how they used to talk to each other during that time? Let's say there are 2 cities with a distance of 50 kilometers. We used to have a line between them. Electric signals. We used to use Morse code. So Morse code mein kaisa hai na? When you have a switch kind of thing, some kind of a plug thing here. So when this thing touches here, electric signal will go. On the other side, there's a small kind of a, alarm kind of thing. So when you press this, you get a sound key. If you press it long, you get key karke. So key matlab dot, key matlab line. Binary code, zeros and ones. So if you get something like key, like this, like key, something of this sort, this is A. You're getting it? So key, something like this. I don't know the alphabets, I'm just randomly saying. Let's say this is D. So the person who is sending should know the Morse code, the person who is receiving should know the Morse code. Even though it looks difficult for us, right? Once you get used to this, now people send messages at such a fast rate You can just hear that sound and you can decode the messages. Normally होता है ना Bollywood movies में. The other side is doing something, hero figures out the message from the icon blinking. Must have seen these kind of scenes. Right? So Morse code where messages used to be sent. And this was especially used for military purposes. You know, this is how Britishers controlled India. What most people don't realize now, think about it. The total number of soldiers in, the British soldiers in India, right, were less than 30-40,000. Most of the soldiers were Indian soldiers only. So when these people, whenever they feel like there's a mutiny, what they used to do? Let's say there are something like 4 or 5 cities here, and they got an information there is a mutiny which is going to happen here. So this post office, right, used to send signals to the nearest cities or nearest, stations. So from there, they used to deploy. Let's say here they have 1,000 soldiers, and they know that tomorrow or day after tomorrow, a crowd of 10,000 is coming to attack. So from here, 2,000 soldiers, 2,000, 2,000, 3,000, 2,000, 4,000, 2,000, they used to gather soldiers there. This was only possible because of communication. So next day when the fight was supposed to happen, there are 30,000 soldiers sitting there ready to deploy. So the entire warfare, right? If you see, it is always about logistics. Sabko lagta hai na war matlab missiles, guns and all. It is always about logistics. You have a tank but no petrol. What will you do with the tank? You have a gun but no bullets. What will you do? You have a soldier who has not eaten food for 3 days. What will you do? Logistics and communication. So this post office had a big problem. You have a post office here. You have a post office here. There's 50-kilometer wire. Something happened, a tree fell down and the wire got cut. You're getting it? Let's say this wire got cut at 9 kilometers and this is 41 kilometers from here. Now you tell me who should go and repair it? A, right?
A.
And you and I know that. But how will the post offices know who has to go and repair? How will the post office know where did the wire got cut? Because see, how do you know wire got cut? Signal band ho jayega na? You will not receive, there'll be always a, did you ever lift your phone? You get a sound. If you take a, landline. Karke. So that they keep it actually wantedly so that, the phone is working. Now that sound goes off, na? That means, wire got disconnected. How will you know where did the wire got disconnected? How will you go? Who has to go and repair it? So the post office box works. Let me show you how that works. So post office box ka basic idea, na, it kind of looks like this. I'm sure you must have seen this in the lab. This is that resistance box actually. This S-shaped thing. So how does this work? Here we have something called plugs. So you have plugs like this. So if you close this plug now, so you can close this plugs. So by closing the plug, you can introduce that resistance. Or you can say it connects the circuit, connects the resistance. Example, let's say you connect a wire between this and you connect a wire between this. If I close this, if I close this, right? And if I close, let's say this. How much is this number? This is 1,000. This is 3 and this is 10. What will be the resistance? 1,000 plus 3 plus 10. That will be 1,013 ohms. You're getting? So by closing different plugs, I can create different values of resistances. Are you sure how this works? So in a post office box, what we do? Basically, we are using a Wheatstone bridge only. It works on the principle of Wheatstone bridge. This is what we do. you'll get questions on this thing, direct theoretical questions. Let me show you one. If you should know the working and how the switches are connected. So we have different plugs here with different values of resistance. You can keep whatever values you want. So we choose few points here. Let's say this point is A. Somewhere in the middle, you take B. Somewhere you take C. Somewhere you take D. So what I'm trying to create is a Wheatstone bridge. And this is the galvanometer. So look at this thing. Let this point be A. Okay. Let this be B. Let this be D. And let this be C. So that means you're connecting the battery between A and C. So you have to connect the battery between these 2 points. Then you connect the galvanometer between B and D. So go like this, jump across the wire, connect the galvanometer across like this. So this resistance is R1, the resistance is R1. Means when you close the plugs between A and B, R1 will change. This is R2. When you close the plugs between B and C, R2 will change. A and D is this big resistor. This is the biggest one, R3. And you connect the unknown resistance X here. Between D and C. Are you getting this? Now what you do, you keep on changing the plugs. When you keep on changing the plugs, what will happen? At one point, the bridge will be balanced. By flipping the plugs. At some point, you get IG0. And if the current is in the galvanometer is 0, means what? It's a Wheatstone bridge. R1 by R3 is equal to R2 by X. From here, I can find the X, which is R1, R2, R3 by R1. You're getting it? Now what to do? So this X is the wire which got disconnected. No? So this is what they do in that post office. See, you have a post office here, and this is the wire which got disconnected. This is the broken wire or something. And we'll assume this wire is touching the ground. So this is the resistance X. This they connected to the Wheatstone bridge. This also they'll ground it. So the circuit is completed. We have a galvanometer here, and we have a battery which is grounded. So using this post office box, I can find the value of X. And what is X equal to? Rho into L by area. What is L? Length of the wire. Rho is the resistivity. A is the area of cross section. From there, I can find AX by rho. This is how I can find the length of the wire by knowing the resistance of the wire. So now when both the post offices do the experiment, this guy will get the wire length is 10 kilometer. This guy will get the wire length is 40 kilometer. Now A and B, both of them know now who is going to repair it. I know distance between you and me is 50 kilometer, and I got the length is 10 kilometer. So obviously I should go and repair it. Are you getting this? शौर्य का डाउट आ रहा है सर एग्जैक्टली 25 है तो क्या करेंगे? हाँ शौर्य, I know that is why you are laughing.
Yes, sir.
पता है रे, तुझे आएगा ऐसा weird doubts. 25 तो दोनों जाके रिपेयर करेंगे. Clear with this? So exam में the question they'll ask is where should the battery be connected? Where should the galvanometer connected? You should know the terminals. So in this thing, right, if you interchange galvanometer and battery, you get the same answer still. Galvanometer and battery can be interchanged. The circuit still works. Check. So there, galvanometer, ammeter, voltmeter, potentiometer, meter bridge, post office box. So make sure to go through this entire thing, right? And you know, when I teach about this post office box, there is a story which I read long back. In UK, this actually happened. There was an old lady, right, who was living in a house with a dog. So, and she had a landline connection there. So one day, she goes to the post office, that telephone office, and complains that, my dog knows when do I get a phone call, and it is a little scary. This is what that old lady complains in the office. Meaning, what? Then they ask like exactly what happened. So she said, my dog starts barking, then I get a phone call. Every time I get a phone call, my dog knows before that and it starts barking. Just imagine you're sitting in the house, you have a dog which starts barking, then you get a phone call. Not once, not twice. Every time I get a phone call, just before the phone call, my dog barks. And it is a little scary. And the telephone office people, they're like, yeah, they thought like, chalo, let's see what happened. Karke. They went for an inquiry. Like they sent someone to go and check it out. This guy checked the phone, everything. He sat down in the house waiting. So someone actually called. Just before the call, the dog started shouting. After the dog started shouting, 10 seconds ago, after 2-3 seconds, you got a phone call. So this guy was actually thinking like, seriously, what? The old lady was not joking. Seriously, ho raha hai. Then he went back and he started checking the whole network. You know what they found? The dog was in a cage, metal cage, tied to that. And this telephone wire which was there, it got broken and it fell on the top of the cage. The other part of the wire was somewhere here. So every time you get a phone call, the dog is getting an electric shock. So the dog is howling. And when the dog gets a shock, it urinates. And the circuit is getting completed and the she gets a phone call. That was the story behind the lady, you know, the dog who knows when there's a phone call. So whenever you get a phone call, the dog gets a shock, it urinates, circuit gets completed because urine is actually conducting because it has sodium ions and stuff. And the phone call gets connected. That is how the poor dog knows when there's a phone call, not because it is evil or not because it had some evil plans to kill the lady. So
How is the dog still alive then?
नहीं क्या होता है ना, if you see telephone wire का voltage is only 50 volts, it is not deadly. You don't die so much. You get a pretty low voltage. It is. You get a shock, but it is not so deadly. You die. Telephone wires have very low voltage. Well, I think they work at around 20-30 volts. It is little shock तो लगता है, but fine. Poor dog. ये शौर्य देखो, she didn't give dog food. That's why she's trying to scare it. Seems. तुझे shock लगाना चाहिए रे. नेक्स्ट टाइम ना जब आओगे ना गेट टुगेदर के लिए, तुझे वही करेंगे, तुझे बीच में बिठा के ना वी ऑल विल ईट अराउंड यू, तू सिर्फ सलाद का तो था वो. You know, there is one more story like this. The car which does not like vanilla ice cream. So there is a family in US. So this guy, right, every weekend na they go and buy ice cream. उस time Swiggy नहीं था. So what happened was, the story goes like this. So this guy, na, whenever he goes to the ice cream shop and orders a vanilla ice cream, the car doesn't start. He goes to the station and, you know, the counter ka order na McDonald's mein se hota hai. So he goes to the shop and says, give me a vanilla ice cream. That guy gives the vanilla ice cream, car doesn't start. Right? It gets stalled or something. But whenever he orders chocolate ice cream, the car starts. Any flavor other than vanilla, car starts. Vanilla flavor, it doesn't start. And this guy was thinking, bloody, ye kya ho raha hai? So this guy goes to the company. It's a big company, right? Volkswagen, I guess. Bada company tha. He writes a letter to the company. Like, first he gives his credentials. I'm so and so, I'm this and this. In my entire proper state of mind, I'm writing this. Please don't misunderstand. Right? My car, for some reason, doesn't start whenever I order vanilla ice cream. I know it looks totally weird and this thing, but do trust me, this is happening. This is not one time. So he writes, the poor guy writes really like scary, like, obviously anyone think you're mad. He writes a letter and the company reads it and said like, yeah, chalo, kisi ko bejo, actually kya ho raha hai? Matlab, that guy kind of credentials he has, he must not be mad. So he actually goes with the guy. Right, that the guy who comes from the company, they sit in the car, they go to the ice cream shop, he orders vanilla ice cream, car doesn't start. And they do something, ho gaya. The next day, right, they go and order chocolate ice cream, car starts. Now the guy who went with him, he's a professional. So first you need to understand, car mein koi ghost nahi hai, nothing is there. So this guy actually starts collecting data. What is the difference between ordering vanilla and chocolate? Mein kya difference ho raha hai? The difference was, maybe it is a kind of climate, the city is in, it is cold or something. When you come with a car and the engine is hot, the fuel, right? It is actually forming a vapor. The fuel is actually forming a vapor because of the engine ka heat. And normally you have this carburetor, this vapor is not letting the fuel get injected into the machine. So normally what happens when the car stops, if you just wait for a minute or two, the engine cools down, the vapor will condense and it works normally. This was a concept. There is something called a vapor lock. There's a concept called vapor lock. This happens actually in engines. It is resolved now. That was a problem once upon a time. It is resolved now. Engines don't have that problem now. But initially that was a problem. People didn't realize. So abhi shop mein kya ho gaya na? Since vanilla is the most ordered ice cream, it was kept near the counter. So whenever he orders vanilla ice cream, he comes, that guy gets the order in 10-20 seconds. And there's a vapor lock because engine is not cooled down. But whenever he orders chocolate or any other flavor, this guy has to go to the end of the room, get the box, get it, build. The time exceeds more than 1 minute. The engine cools down and the vapor lock doesn't happen and the car starts. So they gave him a new car and the Volkswagen company went back and started working on the engine and they made sure it doesn't happen. And next time they told him, if you're ordering vanilla, just wait for 1 minute and then start the car, it works. That is the reason behind the car, which does not like vanilla ice cream. Not a ghost.